Yeah,
Excuse me, sir.
let us start the session.
Hello. Excuse me, sir.
Yeah,
A small doubt, sir. In the R&AC class, HOD sir said that the meets will be conducted from 21st onwards. Is it correct news, sir?
yeah. We have mid examinations. The exact schedule will be shared to you in a couple of days. Maybe today or tomorrow, the schedule will come. Okay.
HOD sir said that it will be from 21st. We have only 4 days left now, sir.
Yeah. Exact date and time today we are going to decide.
Okay, sir.
Okay, and we will let you know by tomorrow.
A small request from my side, sir. At least we need to have 1 week now, sir.
Yeah. We will take care of that.
Okay,
We
sir.
will see. We will discuss with HODs today, and
Sure,
then
sir.
we will let you know by today evening or tomorrow.
Sure, sir. Thank you, sir.
Yeah. Right. So we are into lecture 3. Yeah. Yesterday, we had a discussion on basic strategies of aggregate planning, wherein we discussed about level capacity strategy, which means we always maintain a steady rate of regular time output. That means we don't change the output. We maintain the constant production always. But how do we manage the variations in the demand? The variations in the demand will be managed through inventories, overtime, part-time workers, subcontracting, and back orders. So these are the options we take to meet the varying demands. But in the level capacity, always we maintain the constant production. The second concept which we discussed was chase demand strategy, where we are going to chase the demand. That is matching the capacity as per the demand requirements. So the planned output for a period is set at the expected demand for that period. We have also seen pictorially how the level capacity and chase capacity appear. And we also discussed yesterday about pure strategies. In pure strategy, we consider one example where only level strategy is considered. That means always we produce the same quantity, let us say 1 lakh units. Only 1 lakh units per quarter is produced. Okay. And we solved one problem based on the level strategy. And also the same problem we also solved using chase strategy, where we matched demand to the capacity, wherein we hired and fired workers. And what is the impact of that on the total cost, that also we observed. So those two things we discussed with an example in the last class. And also we discussed about mixed strategy, because level strategy and chase strategy individually may or may not be workable in an industry environment. So always you need to have some constraints. That means you cannot fire or hire the people just like that based upon your varying requirement. So an industry may be having a concept like not more than 10% of the workers will be fired at any time. That is one condition. Similarly, we cannot maintain not more than X percentage or X rupees worth of inventory. So that is another constraint we used. So in the mixed strategy, with the help of constraints, we try to match the demand with the capacity. And also with an example, we discussed transportation method. So up to this, we covered in the last class. Today, let us see what is this graphical method is. So here in the graphical method, we are actually going to plot a graph like cumulative demand values and cumulative production capacities. What is the demand? What is the capacity? We are going to plot a graph between these two. Okay. So what for we are drawing this graph means only to identify the gap between demand and production capacity. Actually, graphical method doesn't provide you an exact solution. It just gives an overview, pictorial representation of the gap between the demand and capacity. Okay. It is just a primitive method which yields less information on the planning. Right. Now, let us take an example. ABC is a company which manufactures roofing tiles. It has developed monthly forecasts for roofing tiles and represented the period January to June in the table. What it is, see here, table. January to June. Okay, it is a 6 months requirement. Expected demand is given 900, 700 like that. The total demand is coming to 6,200 in 6 months. And production days were also given. So in the month of January, they are working only for 22 days, excluding holidays and other things. Okay, only 22 days is a working period for January. Likewise, February 18. So for all the days, by excluding holidays, festivals and everything, totally 124 are the working days in 6 months period for that industry. Okay, so this is the data given to you in the problem statement. Now, this last column is computed by us. We calculate this. How? Demand per day. 900 is the demand in the month of January. 22 days are working. So per day, how many you have to manufacture? 41. Whatever the fraction you are getting, that fraction I am rounding it out to a whole number. So 41 is the requirement in the month of January. Likewise, February, 700 by 18, it comes to 39. So like that, every day in a month, how many you are going to manufacture, that is computed here. Right. The next step is to represent the projected demand. ABC company, it also draws a graph that charts the daily demand each month. And we are going to represent a dotted line. The dotted line across the chart represents the production rate required to meet the average demand, which is computed by dividing the total expected demand by the number of production days. So to understand this better, let me give the example. See here, the example is, here what we are doing, average requirement per day. How we are going to calculate? Total expected demand. Total expected demand is 6,200. That is seen in the previous slide. Here. This is 6,200 total requirement. Total number of days, 124. So 6,200 divided by 124 gives me what? Units required per day. Right? So 50 units are required per day during the next 6 months period. So this 50 units is represented by a dotted line here. So this is called as a level production using average monthly forecast demand. So that's what it is written here. The dotted line across the chart represents production rate required to meet average demand. How it is calculated? Dividing the total expected demand by number of production days. That is 6,200 by 124. This gives me 50. So that is what is represented with a dotted line here, 50. So on the y-axis, we took production rate per working day. On x-axis, January, February, all the 6 months period is indicated. Now, as per the original data given to you, in the month of January, what is your requirement? In the month of January, actually there are only 22 days are there. 22 days and demand per day is 41. So 22 days are there. 41 is the demand for this January month. From here to here, 41 per day you need. Similarly, February, 18 days are there. Your requirement is 39 per day. March, 38. That's what? 39. This is 39. And this is 38. March. Okay. And then April, it is slightly increasing now. April, 57. May, 68. June, 55. So they are all indicated here. April, May, June. They are above the average. Above 50. That's the requirement. So this picture itself at a glance will give you where is the shortage and where is excess. Because if you try to produce 50 pieces per day, if you follow the level production strategy, in the initial days, you may be having excess inventory. This is the excess inventory. All of you agree with that? Okay. You are producing only 50 per day. but our requirement is only 41 here, 39 here, 38 here. So during the first 3 months, we have excess inventory. Whereas in the next 3 months, if you observe, your requirement is more, but your production is only 50 per day. So this picture will, at a glance, gives an idea to the production manager. Okay. This can be represented the other way also. If I draw a cumulative graph, here on the y-axis, I am taking cumulative demand units. Okay, my limit is 6,200. Maximum 6,200 I should get. Right. On the x-axis, I am taking months, but the numbers what I am going to represent here is the cumulative working days. That means January, at the end of the January, I have 22. At the end of the February, I have 22 plus 18, 40 days. Okay. Again, at the end of the month, March, January, February, March, put together, whatever the number of working days are there, that number I will put here. So this is the cumulative working days on the x-axis, cumulative demand on the y-axis. If I plot a graph between them, suppose if I consider this a straight line, this is a straight line. This straight line represents level production. That means every day I am producing 50 pieces. So from day 1 to, if I go up to 124th day, 124 multiplied by 50, I will get 6,200. It is represented by straight line. Every day you are constantly producing 50. That is straight line. But actual forecast is deviating. It is differing, isn't it? This curved line actually represents cumulative forecast requirement. It is varying demand. In the initial months, your demand may be less. If it is less, this portion shows you excess inventory. Okay. Now, actual requirement is more than you are producing. This portion represents reduction. Sorry. This portion represents shortage in the inventory. Okay. So this graph is not exact to the scale. Okay. If you draw exact to the scale, from at the end of the March, this curve deviates up to June. Okay. All of you understood what I mean to say? What is the purpose of this graph? Only to give at a glance when you are falling short of inventory, when you are having excess inventory, so that the remedial steps will be taken. So whenever there is a shortage, you will be thinking about overtime or subcontracting and other alternate methods, right? Whenever there is excess, there can be a firing of the workers to given percentage. Okay, or you may be piling up inventory. Different strategies will be followed by the industry. So this is just a graphical representation of the given data. Are we clear so far? Yes or no?
Yes, sir.
Okay. So that completes the aggregate planning of the third unit. Okay. Now, let us proceed to the next part of this third unit, which is another important topic, that is material requirement planning. Okay. I think students, those who attended automation in manufacturing, a brief outline of this material requirement planning already I gave, I hope. But anyhow, we once again go in detail into this. What is this material requirement planning? It is a computerized inventory control and production planning system. Material requirement is a computer-based inventory control system. Okay. By using which we plan the entire production, which translates master schedule requirement for end items into time-fixed requirement of sub-assemblies, components, and raw material. What do you mean by this? Let us assume that you are going to manufacture a type A product. A is a product that you are going to manufacture. Okay. Now I need 100 pieces in this month. Now, material requirement planning, what it does is, for manufacturing this product A, what are all the components you need? I may need B, C, D. These are all the subcomponents. Okay. So unless you have these three, you cannot make A. Okay. Now using material requirement planning, what we do is, if I have to complete this part A by 30th September, when should I complete this part B? When should I complete this part C? When should I complete this part D? Because unless these three are completed, I cannot make A. A is an assembly which assembles B, C, D. So when they have to, when B, C, D must be manufactured, to tell about that is nothing but time phased requirement. When B is needed, when C is needed, when D is needed. All this work is done by material requirement planning. So suppose C is also having few more components in its X, Y. Then C is called as subassembly. A is the main assembly. C is now subassembly. And B can be only one component. D can be only one component. So the total requirement of A is split into the requirement of B, C, D. And when they are needed, that we are going to compute. So this is called as material requirement planning. Now, what is the objective of material requirement planning? Objective is to improve customer service. How does it improve customer service? If you plan material, how does it improve customer service? I can tell you, when the customer places an order to you, you are promising a particular date for the delivery of the goods. If you have an effective material requirement planning, you may be able to procure the raw material in time, process the raw material, and complete the job and deliver to the customer. When you promptly deliver the goods to the customer, customer will get satisfied, isn't it? Otherwise, if you don't have any material planning, you may not be able to finish the job on time. You may be delaying the delivery to the customer, then he will be dissatisfied. So material requirement planning is very much needed for success of production, which also improves customer service and customer satisfaction. Reduce inventory investment. How does it reduce inventory investment? Material requirement planning will tell you which type of material is needed, in how much quantity, and when they are needed. It will precisely tell how much quantity is needed, when it is needed. If you know about that, you don't unnecessarily stock the material. Is it or not? Unnecessarily, you don't invest money and you don't block your money in storing the raw material. If you have a plan clearly, what type of raw material, how much quantity, when it is needed, accordingly you will procure. So, which also reduces inventory investment. Next, it improves plant operating efficiency. How does it improve plant efficiency? Means, if we are procuring raw material well within the time, missions will not be waiting for the raw material. Always missions will be busy. When the missions are busy, your industry operating efficiency will increase. Otherwise, if the missions are waiting for the raw material, they are idle. Number of mission hours are being wasted. Number of man hours are being wasted. Your plant operating efficiency will come down. So material requirement planning will also affect the efficiency. It improves the efficiency. Now, before studying in depth about material requirement planning, we need to understand a few terms here. First term is independent demand. What do you mean by independent demand? Always it indicates finished products. There is another term, dependent demand. Dependent demand is representing components. Okay, suppose as I gave you the example, type A needs B, C, D. Okay, suppose type A need 100 in quantity, 100 type A products you need, the finished products. For making type A 100 products, for every A, you need 2 B components, 1 C component, 3 D components, let us say. 2 type B components, 1 type C component, 3 type D components are needed. All this, if you assemble, you will make only 1 A. If I want 100 A's, how many B's I need? 200, isn't it? How many C's I need? 100.
100.
D, 300, isn't it? Now, what is the meaning of this sentence is, it makes no sense by forecasting, independently forecasting B, C, D, how much quantity is needed, how many components of B to be procured, how many C to be procured, without knowing this information of end product. It is meaningless to estimate this. Yeah, any doubt? Without having the knowledge of how many finished products are required, without this knowledge, okay, without having the knowledge of independent product, you cannot estimate dependent products, how many they are needed. How do you decide how many B's are needed, how many C's are needed, how many D's are needed? Unless you know about A. So that's the reason why BCD is called as, they are called as a dependent demand. They are depending upon A. If you know how much A is required, then you can compute how many BCDs are required. Right. Now, here in MRP, we always have some assumptions. The first assumption is known deterministic demands. Always we assume that the demand is known to us. Next month, what is the demand? Okay. After that, in the couple of months later, what is the demand? Or for the next 6 months, what is the demand? You know very well. Okay. So we assume that we know the demand for a certain period. Next. Fixed known production lead time. We also assume that production lead time, the time consumed in making a product, is always fixed. 10 hours is taken to make product A, means the 10 hours is constant. That is another assumption. And one more assumption is infinite capacity. Infinite capacity means you assume that machines are already always available. Okay, whenever you bring the raw material, machine is ready to process. This is one more assumption of MRP, infinite capacity. Okay, because of this assumption only, MRP became a failure. MRP was introduced at the very beginning, and it assumed that there is infinite capacity. But in reality, there cannot be infinite capacity in any industry. It is a finite capacity. There are 50 missions, means there are 50 missions only. You cannot think that mission is always available. Mission might be engaged with some other job. Okay. So, but in the initial days, those are all ignored and assumed that there is infinite capacity. Okay. Now, let us take an example. 100 tables. This is a dining table, let us say. 100 tables is my requirement. So is it an independent demand? I'm directly telling 100 tables I want, 100 dining tables I want, which is called as independent demand. Then what is dependent demand? 100 tables requires how many tops? 100 into 1, 100 table tops are needed. How many legs are needed? 100 into 4, 400 table legs are needed. So how we are able to tell this? Because this dependent demand, we compute based upon independent demand. Unless you know this number, you cannot estimate here. That is the reason why they are called as dependent demand. So independent demand 100 tables means it does not depend upon anything. You are directly telling, I need 100 tables. That is your requirement. So based on your requirement, other components will be calculated. This is another way of representation. There can be continuous demand and discrete demand. Here, if I represent on x-axis weeks, first week, second week, third week, fourth week, fifth week, like that. So every week I may be needing 100 pieces. Okay, this may be table legs, let us say. 100 table legs I need. every week. That means I may be manufacturing 25 tables per week. 25 tables per week if I make, every week I need 400 tables. Oh, sorry, every week I need 100 legs. The other way of representation is discrete demand. It is not continuous. Once in a week, it is a 5-day working industry. Every Friday, it is ordering for 400 legs. Okay. Every Friday, it is ordering for 400 legs. Like this. Discrete means you are not demanding for every day or every week. Discretely, once in a week or once in a month or once in a quarter, you may be procuring the material. Then it is called as a discrete demand. Now, what is the difference between independent and dependent demand? Let us understand pictorially. Though I have explained you earlier in the earlier slides. This topmost one is called as what? Finished product. Am I right? The topmost one is the finished product, which is also called as independent demand. Independent demand means demand not related to other items. Right? Then this finished product is having how many sub-assemblies? There are 2 sub-assemblies. Why I am saying sub-assembly instead of component? Because this is getting further subdivided. That is the reason why I am calling it as sub-assembly. To make a finished product, there are 2 sub-assemblies. And each sub-assembly is having 2 components in it. So this is called as a dependent demand. This dependent demand is the main driving force to run MRP. Okay, based on dependent demand only, the entire MRP runs. Finally, we produce a finished product. This is a typical example here. An example, there is a product structure tree for assembly A. This is a final finished product, A. For making A, you need 2 sub-assemblies, B, C. What is this 4 in brackets means? You need 4 Bs to make 1 A. Similarly, you need 2 Cs to make 1 A. Are you able to follow? Any doubt in this?
No, sir.
Yeah. Similarly, B is splitted further. D and E. You need 2 Ds to make 1 B, not 4B. 2 Ds are needed to make each B. Suppose I need 4 Bs means I need 8 Ds. Right? Similarly, I need 1 E to make 1 B. So 2 Ds and 1 E assembled to make a subassembly B. Similarly, 3 Ds and 2 Fs will make 1 C, 1 subassembly C. So I need 2 such subassemblies to make A. Right. The other data given to you is lead times. To make final assembly A, I need 1 day time. In 1 day, I can assemble B and C to make A. Next. 2 days are required to make a B. How do you make B? By using D and E. You will make B. For making B, you need 2 days time. Similarly, for C, 1 day, like this, it is given. These are all called as lead times. Lead time for manufacturing. Okay. Then, one more data is given to you here. Demand. On the 10th day, I need 50 As. Okay, that is my requirement. 50 A. A means a finished product, type A product. I need 50 As on the 10th day. Additional data given is on day 8, some spare parts I need 20 Bs. On day 6, I need 15 Ds. Okay. Now, this is the question given to you. And you are asked to prepare a schedule using MRP. Create a schedule to satisfy the demand. Now let us see how do we do that. Right. First, the number of units of A are scheduled backwards to allow for their lead time. So in the material requirement plan below, we have to place an order of 50 units of A on the 9th day to receive them on 10th day. So what is the question given to you? On day 10, you need 50 A's. So on day 10, I need 50 A's. That is required. Required quantity I wrote on 10th day. Okay. But in order to have 50 A's on 10th day, when you have to place the order, how much is the lead time for making A? 1 day is the lead time. So on the 9th day itself, I have to start working to assemble the part. So if I start working on 9th day, I can complete by 10th day. So 1 day is the lead time. So I'm calculating backwards. So 10th day, if I need the finished goods, 9th day, I have to start working. Okay, I will place the order. Yeah, assemble 50 pieces. I will place the order on 9th day itself, so that they will be ready by 10th day. Okay, now let us see the next level here. Yeah, let us see the next level. Now, here I am going to make A, 50 A's. For making 50 A's, how many B's are needed? For each A, I need 4 B's. So for 50 A's, I need 200 B's. Yeah. So 50 A's are needed, means 200 B's are required. Got it? Now, 200 B's are required. Now, for making B, how many days it will be taking? 2 days. So what I do here, for making 50 A's, I need 200 B's. So when these 200 B's should be available? Can anyone say? I need 50 A's on 10th day. So when should be these B's ready?
On 9th day, sir, before 9.
Exactly, Karthik. On 9th day only. Unless you have 200 B's on 9th day, you cannot start assembling it, isn't it? So you are sure that on 9th day itself, you need 200 B's. To have 200 B's on 9th day, when you have to start manufacturing B?
7th and 8th.
2 days is the lead time for B. So to have 200 B's on 9th day, you have to start manufacturing on 7th day itself. 7th day if you start.
7 and 8. Day 7 to 8.
Yeah. 7th day if you start making B's, by 9th day they will be available. Right? So that you will start assembling A. And 10th day, 50 A's will be available. So we are calculating backwards. In order to have 50 A's on 10th day, on 9th day, what should be ready? 200 B's should be ready. To make 200 B's ready on 9th day, when you have to start making B? 2 days before. That is 7th day. It all depends upon the lead time. Okay. So I wrote 2020 here. What for I wrote there? In the question, they have given demand on the day 8, 20 B. 20 spare parts are required. That is extra. They want to have extra on day 8. So that's what? On day 8, I need 20 pieces extra. So 20 pieces, if I want to have type B, when should I start making it? On 6th day itself. Am I clear? How are you going to calculate MRP? You're always calculating backwards. Shall we proceed to the next? If you understand?
Yes, sir.
Yeah. Yeah. The next important talk we have is what are the inputs and outputs of this material requirement planning? The central part is material requirement planning, MRP. Okay. This MRP is having three types of inputs. The first input is master production schedule. Second is product structure file. Third is item master file. These are the three important inputs for material requirement planning. So by taking these three inputs, there is a computer program which actually calculates several things and finally gives output as planned order release. It gives out order release instructions. When are you are supposed to do, on which day, at what time you are supposed to start the work. All those orders will be given. So these planned orders are three types. One is work order. Work order means directly you are giving to the shop floor people to start the work. The second one is purchase order. Purchase order means you are giving to the outside vendors. You are directly purchasing components. So when you have to procure, all that planning will be given. And the last one is the rescheduling notices. Suppose if things don't work out as per your plan, you may have to deviate. Okay. So if there is a deviation, the entire material requirement planning will be deviated. If there is a delay of one component also, whatever the products depending on that component, for all of them, the schedule will deviate. So you have to reschedule. So these are the outputs. Okay. Work orders, purchase orders, rescheduling notices are the outputs of MRP. Inputs are master production schedule, product structure file, item master file. Now what we do is, could you please mute yourself?
Excuse me, sir.
Yeah.
Sir, you said that material requirement planning is a computerized inventory control, no, sir?
Yeah.
It clearly the company will give all these inputs, sir, for the system like SAP.
Yeah. SAP, of course, once material requirement planning is done, as we discussed already, it is a failure model because it is assuming infinite capacity. The next development is MRP2, manufacturing resource planning. Even that was not successful. Then later came ERP, enterprise resource planning, wherein most of your SAP works. Okay. SAP works on ERP, enterprise resource planning. That means all the activities of the enterprise are integrated in that. That's where we use SAP. SAP is not applicable for MRP. It's a primitive model. Got it? Yeah. Now we understand each and every input. What exactly you mean by that? First, let us take up master production schedule. This one. Okay. What is this input? This is one of the three primary inputs. It states which end items are to be produced, when these are needed, and in what quantities they are needed. This is the master production schedule, which actually drives MRP. Okay. To better understand this master production schedule, which is also in short called as MPS, let us take this example. I think this I have shown to students, those who attended automation earlier. There is a company which is making chairs. Okay. Yes. Why don't you mute yourselves? Okay. Suppose there are three different types of chairs being manufactured in that industry. One is the ladder back chair. Ladder back chair appears like this. Okay. The back seat appears like a ladder. Kitchen chair. See, this chair, whatever you are seeing, this chair is normally used at the kitchen platform or cooking platform. And there is a desk chair. This is for office use. These three different chairs are being manufactured by an industry. Okay. Now, if I have to say aggregately, in the month of April, what is my production? means 670 is my production. If I say 670 chairs I am going to manufacture, I am going to tell it aggregately. Okay, in the month of May, also I need 670 chairs. That is aggregate way of saying. But what is master production schedule? If you divide this aggregate plan into variety of products, that means ladder back chair, I need only 150 in April. Okay, I need 200 desk chairs in the second week of April, 200 more in the third week of April. That means totally 400 desk chairs I need in April. I need 120 kitchen chairs in week 4 of April. If you tell like this, that is called as a master production schedule. Master production schedule divides the aggregate plan into the quantities of each variety and also when they are needed. In the first week, I need 150 ladder back chairs. In the second and third weeks, I need 200 each desk chairs. In the fourth week, I need 120 kitchen chairs. We are telling clearly which variety, in what quantity, when they are needed. If you tell like this, this is called as master production schedule. So in any industry, the aggregate plan will be divided into master production schedule. Okay. Likewise, in the month of May also, the division is given. Okay, that's all right. Yeah. The next one is, I hope you are clear with the master production schedule. The second input is product structure file. Product structure file means this is also called as bill of material. Okay, for every item produced. So what is this BOM, bill of material means? This BOM is a listing of all the raw materials, parts, sub-assemblies, and assemblies needed to produce 1 unit of product. To make 1 unit of product, what are all the components or the sub-assemblies you need? Listing out of all of them is called as bill of material. Right? This is an example, a simple example. Here the product is clipboard. This is the product. Okay, clipboard is the product. Clipboard is having what are all the components? There is a press board. There is a top clip, bottom clip, a pivot, as there is a spring, and there are rivets for this, making this assembly. So you have to divide all the components like this. Then only, if you have all these things, then only you can make the clipboard. The other way of representing this is the main assembly, clipboard. This I call as level 0. Level 0 of BOM, bill of materials. This level 0 is splitted into components. What are they? Clipboard consists of a press board, a clip assembly, a rivet. Why I am saying the middle one as assembly means there is one assembly, clip assembly. The other two are the independent components. Press board is an independent component. Rivets are independent components. They are not assemblies. But middle one, there is a clip, which is an assembled product. So clip assembly can be further subdivided into top clip, bottom clip, pivot, spring. So middle one is level 1. The last third row is level 2. Depending upon the complexity of the product, you can have n number of levels. It is just not 3 levels. This is a simple product. That is the reason why we got only 3 levels. But if it is a complex product you are dealing with, there could be number of sub-assemblies, and then each sub-assembly may have sub-assembly, and each one of them may have components. You will get different levels depending on the complexity of the product. So here, for making one clipboard, you need one press board, one clip assembly, 2 rivets, right? For making one clip assembly, what you need? One top clip you need, one bottom clip you need, one pivot you need, and one spring you need. So this way of representation is called as product structure tree. It is appearing like a tree. It's a tree structure, which is also called as BOM, bill of materials. What are all the components needed for making this? The third input is item master file. So item master file, what it does, what it has, it contains extensive information about every item that is produced. What is that information? Information like gross requirement, schedule receipts, amount on hand, lead time, lot sizes, like that. Gross requirement means, suppose type A, I need 100 in the month of September. This is gross requirement. Second one, scheduled receipts. Scheduled receipts means few components you might have already ordered and you are about to receive them. Okay. There is a schedule to receive. Tomorrow I am going to receive 20 components for which already I have placed the order. That is called as scheduled receipts. Amount on hand. It's not the money, it is the quantity. How much quantity you have already on hand. Okay, let us say type C components. In my stores already 20 pieces are available. So that information will be there in the item master file. Next, lot sizes means in what batches of quantity you are going to procure the material. Lot size, that means type C component if you want to purchase from outside. What is the lot size you are purchasing? Are you going to purchase 200 pieces at a time or 500 pieces at a time? What is the lot size? So all this information will be there in the item master file, because these are all useful for driving MRP, material requirement planning. Okay. Then comes outputs, MRP outputs. As I said, outputs are like work orders. Work orders are nothing but orders released to the shop floor for in-house production. You are sending work orders to the workers to manufacture a certain component in-house. Next, purchase orders means orders released to the outside suppliers to supply some components. Rescheduling notices means revision of due dates or order quantities or cancellation of the order. If the things are not working, if the raw material is not procured in time, then your entire schedule will deviate. Whatever the plans initially you have made, entire thing you have to reschedule. So those rescheduling notices also as one of the output of MRP. Okay. So I will cover up to this today in today's class. In next class, we further discuss about how actually we compute MRP for a given data. Okay. So today we discussed graphical method of aggregate planning. And then we started discussing about material requirement planning. Okay, which is a computer-based inventory control system with few assumptions like infinite capacity, deterministic lead times, and known quantities to be procured. Those are the assumptions. And there are 3 inputs to MRP, like master production schedule, item master file, okay, and then product structure tree, or it is also called as a BOM. And there are 3 outputs which are shown in the picture, like work orders, purchase orders, and rescheduling notices. They are all called as planned order releases. Okay, so today we discussed up to this. Any doubts you have so far? Any doubts? Okay. So let me stop here then. So good day, everyone.